Alright guys, so in the last lesson we talked about graphing to solve a system of equations. Well, now we're going to talk about using substitution to solve a system of equations. Before I get going, here's a nice little quote of the week for you. So, what we think we become. That was by Buddha. So again, like I said, we solved the systems using graphing. Now we're going to use substitution. So this first problem, I just want you to think about it. I want you to pause the video and try and see if you can solve it for yourself. So it says, since Christmas is only about 2 weeks away, Santa's workshop is getting very busy. At last count, there were 26 creatures in the workshop trying to finish up the Christmas toys. Both elves and reindeer were working hard. There were a total of 82 legs in the shop. Using this information, can you figure out how many elves and how many reindeer were in the shop? So again, I want you to pause it right here. Try the problem. All right, there's a bunch of different ways to solve this. Let's see if you can solve it by yourself. All right, so the correct setup way would be like this. So hopefully, again, you tried this, but at last count, there were 26 creatures in the workshop. So we know that x plus y is going to equal 26. Well, first off, we need to figure out what our x is going to be. So let's say x is going to be our elves, y is going to be our reindeer. All right, so we know there's a total of 82 legs in the workshop. Well, how many legs do elves have? Well, that's 2. Plus, how many legs do reindeer have? Well, that's 4. I want it to equal 82. So now, using substitution, this is how this works. You either want to solve for an x or for a y. So if I take that x plus y equals 26, and I subtract the y over, I get x equals 26 minus y. So I know x equals this on that top equation, so I can plug that in for the x in the other equation and solve it. So now I was going to say 2 times 26 minus y, because that's what x equals, plus 4y equals 82. So now, just solve it for y. I would distribute. I would get 52 minus 2y plus 4y equals 82. Subtract 52. I'm going to get negative 2y plus 4y equals 30. Go ahead and combine your like terms. So y there it should be 2y equals 30. Divide by 2. I know that there's going to be 15 reindeer. Well, if there's 15 reindeer, can I figure out how many elves there are? Well, yeah. I can plug that back into the equation that we adjusted. So x equals 26 minus 15. X equals 11. So there's 11 elves and 15 reindeer. If you solve that by yourself, awesome. Right? So what we used there was called substitution, and that's what today's lesson's about. So it says, what is the solution of the system of equations? If you ever see a single y or a single x like this, like y equals this, you're probably going to use substitution. That's just a method that we talk about. So I'm going to sub this part in for the y in the other equation. So I'm going to rewrite it and say 3x minus 8, and instead of writing y, I'm going to say 6x plus 7 in parentheses, because you are multiplying. And then I'm going to distribute. So I'm going to get 3x minus 48x minus 56 equals 4. Negative 45x minus 56 equals 4. We're going to add 56. Negative 45x equals 60. And then I'm going to divide by negative 45. All right, when you type this into your calculator, 60 divided by negative 45, you get negative 1.3 repeating. What I want you to do is I want you to hit second PRB on your calculator, and it'll take it from a fraction to a decimal. And then you're going to hit second ABC to convert it to an improper fraction. So really, this is negative 4/3. These are the same thing, but the negative 4/3 is a lot easier to work with. So now what I can do is I can take that and I can plug it in for the y equals 6x plus 7. I know what x is now, so I can plug it in and solve it. So if I substitute in negative 4/3, I get 6 times negative 4/3. You get negative 8 plus 7. So your y is negative 1. So we write our answer as a coordinate pair, the x and then the y. So negative 4/3, comma, negative 1. Right? And what you want to do with this is system of equations. You can always check and see if it works. Well, we know it works for the first equation because I would take negative 6 times negative 4/3, add 7, I get negative 1, which is what we're after. Let's see if it works for the other one. So I'm going to take 3 times negative 4/3 because that's my x value. So you get negative 4. So I'm going to write this in black up here. And then you're going to take negative 8 times negative 1. So that's a positive 8. And I want it to equal 4. Well, negative 4 plus 8 is 4. So it works. So I know that is the solution. Again, you can always plug it back in and check it to make sure it works. Right? So I'm going to encourage you to try this top problem. I know we just did one example, but I want you to pause it and try it. All right? So hopefully you've attempted the problem. I'm going to substitute y plus 6 in for the x. So I'm going to say y plus 6 plus y equals 10. So 2y plus 6 equals 10. Subtract 6. 2y equals 4. Divide by 2. Y is 2. So now I can take that and I can plug it in to the x equals y plus 6. And instead of saying y, I'm going to say 2. And I get x equals 8. So your answer is 8, 2. And again, you can double check it and make sure it works. It does for the first one. 8 plus 2 is 10, so it does for the second one, so we're good. Same thing on this next problem. I want you to pause it and try it. See if you can get the correct answer. I'm going to substitute in 2x minus 1 in for this y. So I'm going to say 2x plus 3 times 2x minus 1 equals negative 7. I'm going to distribute. 2x plus 6x minus 3 equals negative 7. You get 8x minus 3 equals negative 7. I'm going to add 3. 8x equals negative 4. Divide by 8. You get negative 0.5, aka negative 1/2. Alright, so now I'm going to take that. I'm going to substitute back into the original equation. I'm going to say y equals 2 times negative 1/2 minus 1. And I say y equals negative 1 minus 1, aka y is negative 2. So again, you can always double check it, write it as a coordinate pair, see if it works for both equations. In this case, it does work for both equations, so I get negative 1/2, negative 2. All right, just some more examples for you to try. So this one, I'm going to substitute the 3x plus 1 in for the y here. If you do that, notice whenever you distribute, you get negative 6x plus 6x. So they cancel, so I get negative 2 equals negative 2. Well, you got to ask yourself, is that a true statement? Does negative 2 equal negative 2? Well, the answer is yes. So that's going to be all real numbers. Or another one that I like to say is infinitely many solutions. But they mean the same thing. All right, so if you get negative 2 equals negative 2, it's going to be all real numbers, or like 3 equals 3, 6 equals 6. There's a bunch of examples you could do there. All right, so the bottom, let's go ahead and try it. Plug it in. Well, what happens here is I got to distribute that negative. So I get 5x minus 5x plus 4 equals negative 4. So your 5x's cancel, so I get 4 equals negative 4. Well, does 4 equal negative 4? So the answer is no. So the answer to this one would be no solution. All right, so those are two special cases. I know we talked about them in graphing as well. But now whenever you solve it, if you get something like this, like 4 equals negative 4, 8 equals 0, something that's not true, your answer is no solution. And then we kind of roll into a word problem, just kind of to see how you guys are doing with this stuff. So it says fun time amusement park charges $12.50 for admission and then 75 cents per ride. Well, I'm going to say y equals 75 cents per ride is like your slope, plus 1250 is my y-intercept. So that's one equation. I'm going to say Rivers Edge Park charges $18.50 for admission and then 50 cents per ride. So I'm going to say 0.5x plus $18.50. Now the answer I'm trying to find is for what number of rides is the cost the same? Well, if you think about it, they're both y equals. So I could take this and plug it in for this y. Because I'm trying to figure out when they're the same. So I'm going to say 0.75x plus 1250. When is that going to equal 0.5x plus 1850? Right? So I'm going to subtract the 0.5x over. I'm going to subtract the 1250 to the other side. So I get 0.25x equals $6. Divide by 0.25. Type that into your calculator. You get, after 24 rides, is when their cost is the same. All right, so that's an example of a word problem and how you can use this in real life. If you guys have any questions, please let Miss Sanders or myself know. We'd be more than happy to help you. Your homework is going to be 4.2 Pearson. With that being said, I hope you got the most out of the substitution today. Remember, you can always graph, double check it as well, but substitution is a little bit easier because it's just purely math-based. You don't have to get it to y equals mx plus b form like we're used to. All right, so have a good day. If you have any questions on homework, make sure you reach out. Bye, guys.